and I will be starting the Facebook live session, okay? So hi everyone who's joining us. We will start in just 1 minute. Right, so this webinar is live streaming and the attendees are joining us. Thank you, welcome. Hola, hola, Bárbara. Perfecto, pues bienvenidos, buenas tardes a todas y todos. Mi nombre es Fabiola Velarde y soy parte del equipo de FERLAC Jalisco, trabajando desde el componente de emprendimiento. Muchas gracias por acompañarnos en esta charla sobre inteligencia artificial. Estamos muy emocionados de contar con el equipo de IBM. Y les compartimos que al finalizar esta sesión vamos a tener un espacio para preguntas y respuestas. Les pedimos que por favor las escriban, si puede ser en inglés, porque esta charla va a ser en inglés en la parte de la sección de Q&A, o bien si están siguiendo la transmisión vía Facebook, en la parte de comentarios, también de ahí los vamos a poder extraer acá a la charla. Antes de iniciar, queremos mostrarles un video sobre la iniciativa de FERLAC Jalisco. Este está en inglés porque, bueno, la charla está en inglés con este speaker.
FAIRLAC Jalisco is an initiative led by BID, Inter-American Bank of Development for its acronym in Spanish. The technical logic of Monterrey University, Jalisco's government, and Sea Mines. The FAIRLAC Jalisco initiative works through the articulation of academy, civil society, public sector, and private sector in 3 important areas. One of them is the implementation of technological solutions through artificial intelligence techniques to solve social problems in Jalisco. Another one is the advice when creating public politics for the use of artificial intelligence, such as its ethical and responsible uses. FAIRLAC Jalisco is part of the hubs that have presence in Medellin, Colombia, Costa Rica, and Uruguay. Jalisco has a unique differentiating factor, the entrepreneurial component seeking to strengthen the entrepreneurial environment in AI through the following activities. AI Startup Acceleration Program, PASIA for its acronym in Spanish, AI Talks, workshops on the integration of responsible artificial intelligence and venture capital, hackathons, and the analysis of Jalisco's environment of entrepreneurship in artificial intelligence. FAIRLAC, for an ethical and responsible use of artificial intelligence.
Gracias, Pris. Y bueno, para dar inicio con esta charla, vamos a hacer aquí un cambio ahora sí al inglés y dar la bienvenida a nuestra speaker. Ella es Ana María. Ana María es Manager, Data Scientist, Machine Learning Engineer on the IBM Data Science and AI Elite Team, and leads a team of data scientists in the North America region. She works with clients globally, helping them become successful on their journey to AI, Being a lifelong learner, she has a diverse educational background, including computer science, big data, analytics, transport engineering, psychology, and economics. She held previously position as a general manager and EMEA regional manager for international organizations, effectively using data to drive business decisions while managing and growing the business. Ana Maria, welcome. Thank you very much for you're here to be here with us, and we're very excited to hear all about the talk you have for us. So the microphone is all yours.
Thank you very much, Fabiola, and welcome everyone to this presentation this evening. I'm really glad that you all joined. And first of all, I would like to apologize. I don't speak any Spanish at all. And people always make fun of me because of that, because my name is Ana Maria, and they normally just look at me like, what, with this name, you don't speak any Spanish. So yeah, so the presentation is going to be in English, but if at any point you think that you need some clarification or something wasn't clear enough for you, please feel free to contact me if you want to, even after the presentation as well. My native language is not English either, so yeah, so it's gonna be probably exciting from both ends, but yeah, so let's just start it. So at first, let me just share my screen, and then, all right, so hopefully you will be able to see my presentation slide right now.
Yes.
And thank you. So first of all, I wanted to explain to you what I'm planning for this evening session. We are going to continue with a little more introductions, and that's going to be about my team, where I'm based at within IBM. And after that, we are going to jump onto some AI fairness basics. For example, we will discuss why AI fairness is important. What is AI fairness at all, and we will discuss a couple of types of fairness and also how we measure fairness. And then after that, we are going to change gears a little bit, and we will step into the shoes of a data scientist, and we will see what data scientists normally do when they create algorithms and how we can add some fairness conscious steps to these processes. And then after that, I will introduce you to a couple of toolkits that you can actually use if you want to learn a little bit more about AI fairness. I will show you two different routes. One of them is if you are not really happy to code and you just want to play around a little bit, then I will introduce you to a little demo that you can try and test at home. And I will also show you some notebooks and codes that you can actually learn from if you are more on the coder developer side. And we will also do a little literature review. So not so long ago, I completed research at the University of Liverpool, and I will introduce you to a couple of research papers that I found really helpful when I worked on the topic of AI fairness. All right, so with that, let's jump on. First, just wanted to tell you a little bit about the IBM Data Science and AI Lead team, so that just you have an idea where I sit and what we normally do. So my team was established about 3.5 years ago, and our mission is to help our clients on their journey to AI, no matter where they are. Some of our clients are in the very beginning of this journey. They are just about to establish their data science practice. And some of them are already very advanced. So in that case, they already have models in production. But no matter where they are, we are always helping them to get a little further ahead in that journey by teaching them the newest methodologies, technologies in the AI space. So wanted to mention it to you as well, why I actually picked this title on the journey to AI fairness. If you have been participating in technology conferences in the past couple of years, or if you read some news, magazines, etc., or read some media about AI in general, then I'm sure that you have seen it that AI fairness itself has become a very widely discussed topic recently, and that's why it became the focal point. However, there is still a significant knowledge gap there. So especially when it comes to the application of the different bias mitigation techniques and methods. And there are also a lot of research efforts going on right now. So there are new papers coming out and research studies technically frequently. And that's why, in my view, we are on the journey to AI fairness. We are not quite there yet, but we are on the journey, and we are all on this journey together. Now, why is AI fairness important at all? So why is it such a hot topic nowadays? AI has been adopted across many different industries, and machine learning and AI algorithms can actually make very important decisions, and some of these can actually influence or make an impact on people's lives. So I took a couple of examples here just to emphasize this. For example, machine learning algorithms are used in criminal justice. So officers frequently use algorithms just to determine who gets on parole, for example, or who doesn't. Or during credit approvals, if you apply for a loan or for a mortgage, then you might see that, well, you might not, but your officer your loan officer might actually use some sort of AI algorithms, or the bank or the loaner or lender. And that helps them make a decision who gets the credit or who doesn't. And also in hiring, many organizations already use some sort of predictive analytics in order to see which candidate might be successful in that job and which doesn't. And also my team worked with many healthcare providers, hospitals in the medical settings in order to create some algorithms to help diagnostics and also predict outcomes of some sort of treatments or medications. So as you can see, it is very important because it has a consequential impact on humans' lives. And it happened already a few times in the past as well that biased algorithms, machine learning algorithms were introduced by organizations which discriminated against certain group of people or certain individuals. And technically the aim is to ensure that we don't put any biased algorithms into production. You might have heard of some of these examples. I wanted to discuss two of them. One of them is the famous analysis which was run by ProPublica. And they were analyzing Compass, which is a tool which helps assess criminal defenders' likelihood of reoffending. And in that particular case, Compass appeared to be biased, and it made more favorable decisions for white defendants as opposed to Black defendants. So technically that meant that Black defendants were more likely than white defendants to be incorrectly judged to be at a higher risk of recidivism. And another famous use case was what Reuters reported about. In that particular case, there was gender discrimination detected in a recruitment process which was applied by the organization Amazon. And in that particular case, if the machine learning algorithm was trained on historical data, and in a case if developer jobs were, for example, assessed, then the machine learning algorithm selected mainly male applicants, and with that it discriminated against the female applicants. And that was because the machine learning algorithm learned the patterns and characteristics from existing data, the past 10 years period of data, and historically in these particular jobs and developments, there were more men than women. And that's why the machine learning algorithm did not learn so much about the underrepresented group and started making biased decisions against women. And within my team, the data science and the AI elite team, we already worked with many organizations together successfully, which aim to ensure that there is no bias in their decision making. And one of these use cases was actually very similar to what I just mentioned before. It was regarding hiring and hiring processes, where the organization wanted to make sure that they don't discriminate against any group of individuals. In many countries, there are so-called protected attributes or protected groups, in which case by laws and regulations, it is not possible. We should not make any biased decisions against, for example, race, gender, age, and so on. So in this particular case, we leveraged Watson OpenScale in order to help determine if there was any bias in the algorithm and then mitigate the bias, and also help the stakeholders of the organization to see how a particular decision was made by the model. And as next, I wanted to explain how difficult it is actually to define what AI fairness means. So I've been talking about AI fairness for a while now, so probably this is a good point to actually speak about what it means or what it is. But believe it or not, it's actually not that easy to define AI fairness. And in a presentation, Professor Arvind Narayanan, who is at the Princeton University, he counted that there are 21 bias definitions out there, and most of these actually contradict each other. And another interesting finding by Friedler and all is that if you want to define AI fairness, then first of all, we must begin considering how people are desired to be treated and what level of similarity needs to be achieved between groups or individuals. And then these two considerations will determine the definition of AI fairness. And another interesting study by Salero and all was to state that AI fairness is not an absolute concept. It is in fact context dependent, and therefore it requires very careful thinking what the application is of the AI model, who are the stakeholders, or who are the groups or protected and vulnerable groups of people as well. And then we can define the way going forward. And then in another study, Friedler also mentioned that there are many different worldviews which are normally taken, and that is exactly why the fairness definitions are so incompatible with each other. And also there is an impossibility theorem out there, which actually states that it's not possible to satisfy all the fairness metrics at the same time mathematically. So let's see first, like what these worldviews are. Now, there are two worldviews that we want to define here. One of them is WYSIWYG, which is technically saying that what you see is what you get. So in this particular case, we state that the observation reflects the ability to perform a task. And in that particular case, we allow correlation between a group of individuals and the outcome. Now, just to put this in context a little bit, I have an example here, which is the SAT score. The SAT is a standardized test, which is mainly used in the United States for college admissions. So technically, the higher the score is, the better it is, because then it is more probable that the student is going to get a placement in a college admission. So we can ask the question that, is the SAT score a true reflection of future academic success? Now, if we follow the WYSIWYG approach, then we will say that yes, it is indeed, because we are allowing the correlation between the level of SAT score and the academic success. So if someone has a high SAT score, then most likely they are going to have success in their academic studies and lives as well. However, if we are taking the other approach, which is called we are all equal, in that case, we say that the SAT score should not be the deciding factor for college admissions, because it can already include some sort of structural biases. So, for example, let's say that the student who scored lower on the SAT test might have come from a different background, from an non-English speaker background, and maybe that's why it was more challenging for them than for non-native English, or maybe they came from a low-income family, they didn't get into good high schools, etc. So these biases are already built into the SAT score, therefore we shouldn't really use that particular attribute in order to define whether or not they are going to be successful in their academic life. So in that case, we say that there should not be any discrimination based on the group membership, given that the performance of the group members with respect to the task follows the same distribution in each group. So if we have a bunch of individuals who scored very high in their SAT score, there will be still people in that group as well who is not going to succeed in their academic life. So there will be still a normal distribution in that group as well. And similarly, in the lower scores, even if they scored lower, there might be still people who are going to be more successful than the others. So in a strategic organizational decision or choice, we would need to establish which way we want to go and what we would like to follow in terms of decision making, because there may be different fairness metrics and techniques that we might want to use in each individual case. Now, I also wanted to tell you what I use for this presentation for fairness as a definition. This is not something that is set in stone. So this is technically just my view on it. So in this particular case, we are going to speak about fairness as the absence of unwanted bias or discrimination and the fair representation of human values algorithmically. Now that we sort of defined what fairness means for us on this call today, we can try to categorize the fairness and bias. And if you read the literature, then there are so many different categorizations out there as well. So in this case, I will only discuss 3 of them. One of them is based on the intent. The other one is how bias appears in the AI model. And the other one is from the perspective of the individuals. Now, if you are talking about the intent, then we can distinguish between intentional and unintentional bias. So here we argue how much decision makers can be trusted in the decision-making process. And we assume that there might be some malicious attempts to discriminate against certain group of individuals in some cases. Now, if there is something malicious or malicious, then in that case, it can be challenging to spot it because of the nature of it. So in that case, most probably, if someone wants to make a biased decision, then they are going to try to cover that as well. However, there are different type of techniques to solve these problems, and one of them was presented by Feldman et al. And they sort of studied how well the protected variables can be predicted from the non-protected variables. So just to give you an example here as well, let's say in the academic decision-making, someone wants to discriminate against Black students. So in that case, they might not actually use the race in the algorithmic decision-making, but they might use some other attributes which can correlate with the religion, sorry, with the racial background as well. So, for example, if we don't use race, but for example, we start making decisions, like we don't accept applications from a particular high school, and that high school is in a zip code or postal code, which is related to an area, geographic area where Black communities live, and therefore most of the students in that particular high school are Black, then we actually might have discriminated against the Black individuals as well, even though we didn't directly use the race in the machine learning algorithm. Now, for this particular presentation, we are not going to speak about these intentional bias and decision-making, but we will only focus on the unintentional bias, which means that the bias just somehow found its way into the algorithm without any malicious attempt or without any harmful thoughts behind it. Now, the next one is based on Lloyd's paper in 2018. They observed and studied how bias appears in the machine learning model, so how it can actually make its way into it. And there are different ways of that. One of them is the data set bias. So in that particular case, it occurs when the model is trained on a data set which already includes some sort of bias. It unfairly represents a group of individuals. So if you think about how machine learning models normally are made, when we train a machine learning algorithm, then it normally reads and learns from historical data set. So if that, and then later on, it will apply that knowledge that it gained from that data set in order to make future decisions. So that is why if the data set was biased, then most likely it's going to make some biased decisions as well. Association bias, it's in this paper, it mainly talks about the cultural biases, which might be reinforced in an algorithm. So if you go back to the hiring use case, for example, then in certain cultures, women don't work in particular jobs or roles. And in that case, if you train the model in that particular region or based on that information, then and then try to scale it up later on to other cultures as well, then this cultural setting is reinforced by the algorithm. Now there is another one which is interesting. It's the automation bias. It originates from the discrepancies between human goals and the understanding of the machine of the expected outcome. So technically the machine learning algorithm sort of misunderstands what your purpose was or what you were trying to achieve. Maybe you didn't set out the machine learning question too well from the beginning. Interaction bias, this is also an interesting one. So that can happen actually when we use self-learning machines. And in that case, it picks up, it can pick up on some behaviors from humans, which can be harmful or it can be malicious. So just an example, if you want to teach a chatbot, then we train our chatbots from YouTube comments or Facebook comments, and sometimes there are those comments from users that that are not particularly nice, or use bad language or inappropriate responses, etc. And if this self-learning machine learns from an uncontrolled environment, so these are, for example, not filtered out, then it might be that your chatbot will end up giving you some very inappropriate answers to your questions. So, for example, it swears or anything like that. Now, the other one is a confirmation bias that occurs when the generalization is sought from a very narrow set of information about a certain group of individuals, and that actually confirms our previous beliefs. That can be quite frequent as well, because sometimes you don't even realize when you set out your machine learning question and also the structure of it, that you are actually seeking a data set, or not even a data set, you are using a sample of individuals, for example, which is actually biased in a way. You don't have a representative sample there, and then you may actually confirm some of your previous beliefs by just setting out the machine learning algorithm without even recognizing it. So that is why it's important to make sure that we are actually measuring bias throughout the machine learning building, and also before we put the models into production. Now, the other one is the perspective of individuals, which is probably one of the most important categorizations. Here we can distinguish between group fairness and individual fairness. In group fairness, you want to make sure that similar groups are treated similarly. So this comes back to what I mentioned previously, when we want to ensure that we don't discriminate against certain gender, race, age, or anything like that. And the other perspective is from the perspective of individuals in terms of individual fairness, when we want to make sure that similar individuals are receiving similar treatments. Now, when we set out our machine learning questions as well, then we sort of need to consider which way we want to go, group fairness or individual fairness. Some of the metrics actually work for both of them as well. Now, talking about metrics, and that's also an interesting one, because right now there are more than 75 bias metrics out there, which are very frequently used by the practitioners. So it can be probably a little confusing sometimes which one to use and which one not to use. And I wouldn't even attempt to sort of explain all of these on this particular call today. But at the end of the presentation, I will show you a good tool where you can actually look up these fairness metrics and read a little bit more into them as well, and also about their application. But just to make it easier, I normally like to categorize these fairness metrics based on how they are derived. So there are some fairness metrics which are distance-based. So they measure the distance between data points, and then the metrics are obtained based on that. Some of them are looking at similarities between the data points, and some of them are derived from what we call the confusion matrix. So if you have done classification tasks before, then most probably you heard about true positives, true negatives, false positives, and false negatives. And some of these bias metrics are also derived from these values. And then the last one is demographic parity. That is probably the most well-known. And in that category, we have disparate impact and statistical parity difference. I will show you a very quick example on the calculation of disparate impact and statistical parity, and I will also pick another one from the confusion matrix category. And if you are not a big fan of math, then probably look at the blue box, or otherwise you can look at the white bubble as well, but I will talk you through this hypothetical example anyway. So let's say that we are recruiting managers and we would like to make sure that we are not discriminating against a group of individuals in our hiring process. And let's say that in this particular case, we want to make sure that female are equally represented and we give them equal opportunities. Now, if we want to calculate the disparate impact or the statistical parity difference, then we would start the same way. So at first we would take the ratio of the successful female candidates and within all the female candidates. So we are calculating this ratio first, and then after that we are going to do exactly the same for the male candidates as well. So ratio of successful male candidates divided by all of the male candidates. And now in the case of the disparate impact, we will just divide one number with the other, and statistical parity difference, we will just subtract one from the other. And then we have a look what we get and how close we are or how far we are from the ideal value. So the ideal value would be 0 in disparate impact, and for statistical parity difference, it's 1. So if you see that, okay, so we are having some sort of bias here, then we would go on to the next step and try to figure out how we can mitigate this bias before putting our algorithm into production. And if we want to calculate some other metrics, for example, equal opportunity difference, then we would see the true positive ratio of the unprivileged group, and we would subtract the true positive rate of the privileged group, and then see what we get. And then again, we would see how that compares to our ideal value. And in that example, that would be 0. So if we are far out, then obviously there is some bias in our decision making, and we would get on to the next step, which would be some sort of intervention. Now, okay, so that's great, but how do we actually do that? So how do we make sure that our algorithm that we build is fair? And that's why I'm going to show you an example and the process flow, which is frequently used by data scientists. So we are going to step into the shoes of a data scientist. In practice, many times we use something that we call cross-industry standard process for data mining, CRISP-DM. And that is technically a machine learning lifecycle that we follow. We do that with my team as well. And the cycle normally starts with working on our business understanding. So this is the time when we sit down with the stakeholders and then discuss the use case, what we want to resolve with machine learning. And then we go and have a look if there is any data to support our use case, because technically data is the life and the blood of AI. If there is no data, there is no AI. So once we got the data, then we normally start working on our understanding, data understanding. So this is when we do a lot of statistics and analytics to look what we have on our hand, and also see for any problems with the data. For example, if we have a lot of missing values, or something is just not right, or something is just inconsistent with the data, then we can always get some clarifications from the business or the data owner before we actually proceed any further. So in that case, the next step, if we already have the data, worked on our data understanding, and we start preparing the data for the modeling. So this is when we start massaging it a little bit and transforming it just to make sure that it's actually good for our machine learning algorithm. This is also when we extract some new features and so derive some new features from the existing ones, and also select what we would like to keep or not keep for this machine learning task. And then once we are done with that, then the most exciting part comes, that's the modeling. This is when we actually start writing the code for our algorithm and putting together the machine learning model. I can say that this is the best part of it all, that most of the data scientists love the most, but that's also probably one of the shortest one, because all the steps before that take up almost like 80% of our time. So we train our machine learning model, and then after that we need to evaluate it. This is when we see how it actually performs, we test it, and if we are satisfied with it, then we deploy it. That is when we make it available for the business users to score and use the model. And if we are not satisfied, then we can always look back 1 or 2 in the cycle and make some adjustments there. So this is the normal process flow, but how can we make sure that we actually build in some sort of fairness conscious steps into this cycle? Now, there are many different ways of doing it, and we can do it technically throughout the entire cycle, but then of course there are some constraints when and what we can do, and those constraints might actually come from our business. In particular cases, it might be that the data scientist is not allowed to touch certain elements. For example, we are not allowed to see anything from the modeling part or the data, and in that case we have no choice, only work on the outcome of the model and try to modify that. And for some organizations, there are some requirements which need to be satisfied, and we can't just use any type of algorithms. We need to make sure that we don't use a black box model, for example, for example. So we need to work with all these constraints as well when we work out our strategy, how to mitigate fairness and measure and mitigate fairness. So let's see the first one. What can we do in the planning and designing stage? Now, I mentioned previously that we need to define it for ourselves and for our business and use case, what AI fairness means for us. And also we talked about organizational views and requirements. Now, another interesting topic is the legal or ethical requirements. In this particular presentation, I'm not going to go into those topics because that's a very, very broad topic as well. So in that case, that would deserve an entire new and different presentation. And also we would need to see if there were any historical discrimination in the past that we know of, because in that case it actually allows us to look for something, so we know what we are looking for, which helps. And then, as I mentioned before, sometimes there are some constraints, what we can do or cannot do. So we need to discuss that with the business in time as well, what we can access and change in the process. Now, the next one is the pre-processing part of it. So in the data understanding and the data preparation part, we can actually apply a couple of different mitigation techniques. We normally use these techniques when we are allowed to access the data, and we are also allowed to modify it. Now, there are many ways of doing this algorithmically as well. We can, for example, reweigh the data sample. As I mentioned previously, it might be that some of the groups are underrepresented in our data set, and in that case, the algorithm might not learn too much about that group. So we might just reweigh or assign new weights to the privileged and unprivileged groups. And there are some other ways as well, which I don't want to discuss in broad details, because I wouldn't assume that you would get away with that knowledge hearing the first time, but I will show you some more information later on this presentation, just to see where you can find and also play with these different type of mitigation techniques and see by yourself how they work and what they do and what they can't do. And we can also use in processing techniques. This is when we actually apply some sort of algorithmic approach, and we embed the bias mitigations already in our machine learning model. And we use that if we are allowed as data scientists to actually change the machine learning algorithm that we use. And yeah, so for that as well, there are many different techniques and algorithms that can be applied. And you can also use it if the previous method did not work, then you can always skip on to the next one in the cycle and try that as well. Now the last one is the post-processing technique. And this is when we already tried, exhausted everything in the previous steps, didn't work, or we are just simply not allowed to see anything, how the model was put together and what data it used. All we can do is really just to see the outcome, just to see the predictions by the algorithm, and then make some inferences on that and change the outcome of the prediction. All right, okay, so probably that was already quite a lot of information so far. And I wanted to show you a couple of things, how you can start your journey to AI fairness, even if you are not a coder and you just want to learn a little more about the concepts, or if you are indeed a coder and you would like to play with some notebooks and codes as well. Okay, sorry. At first, let me just skip on one more thing. Just to introduce the concepts of AI Fairness 360 and what's on OpenScale as well, because these are technically the two toolkits or well, technically tools that I want to describe later on. But first, why are we talking about open source here? So from the very beginning of open source, IBM has already been one of the major contributors. And the reason for it is that we really believe that open source is critical to move the technology forward. And this allows a lot of collaboration between developers and sharing skills and expanding the open source ecosystem. And IBM actually has contributed to AI fairness related libraries as well. So for example, we have the AI Fairness 360 that I wanted to discuss here today, probably in more details as well. AI Fairness 360 is a comprehensive AI fairness toolkit, which embeds all the current findings, current research findings. So it actually enables the data scientists and the AI practitioners to just access it all through one toolkit. So it embeds most of those fairness metrics that I mentioned, more than 75 of them. It includes 10 bias mitigation algorithms, data sets to practice on, notebooks, glossaries, tutorials, etc. And there is also AI explainability 360, and that helps explain the machine learning modeling, predictions, and also adversarial robustness 360, which allows the analysis of attacks, defense, and detection methods for machine learning. And apart from that, we also have what's on OpenScale, which tracks and measures the outcomes of AI across its entire life cycle. And it has three very important pillars. One of them is bias detection, explainability, and model validation. So I will talk about all these three a little bit more. And yeah, so let's start with bias detection. So in that case, OpenScale enables the enterprise to enforce fairness in their model outcome, and it analyzes transactions, and it can detect bias, pinpoint where the bias is actually originating from, and also it can help eliminating bias by different mitigation techniques. The other pillar is explainability, which is really important to make sure that we actually know how the machine learning algorithm made a decision, because in many cases I hear from organizations that they are reluctant to use AI because they don't trust it, they don't know how particular model decisions were made. So in that case, explainability function is really great because it can actually track down a simple decision, how it was made. So for example, if a loan officer is curious about why Mr. Smith's loan application was denied, then we can have a look at that particular transaction and see that what were the main features that the algorithm decided that this makes the person a risky individual. And model validation, that's also important to know that when we train and test a machine learning model before putting into production, then it learns from historical data that was valid at that time. However, sometimes there are some underlying data patterns that change over time, and therefore what your machine learning algorithm learned in the past is now no longer applicable, and therefore there will be a drift in the model performance. So if you just think about COVID, if we trained our algorithm prior to COVID, now market changed in many situations, and it might be that that particular machine learning algorithm no longer predicts well, and with OpenScale we can detect that, and also we can retrain the model based on new information. And these toolkits actually work together. So what's on OpenScale includes everything and embeds everything from AI Fairness 360, and it also adds to it from latest research finding, and we also add runtimes, algorithms, etc. So technically, what's on OpenScale is the next step upwards on our journey to trustable AI. And if you want to try, then you can always go on to these links here that I'm providing, and you can sign up for a trial version or a light version of Watson Studio and try it out by yourself as well. But I will also show you a website. So I'm going to come out of presentation mode from now, and I will show you this website here, which is AI Fairness 360. And I would recommend you to have a look at this page and go through the various tabs here. There is an ocean of information about AI fairness here. You can read the latest papers, watch videos, use some tutorials, and also you can try a web demo. And if you want to, then you can have a look at the API documentations as well. And I mentioned to you that there are a lot of metrics as well that you can use. So technically you can also go and sorry, yeah, this is what I wanted to show. Have a look like what the equations are and what exactly those metrics mean or measure, how they work, because obviously we don't want to keep everything in, we can just learn absolutely everything. And it works very well as a reference material as well. Or if you want to, then you can also get onto the GitHub page. And yeah, let me just try to go back to it. And then on the GitHub page, technically you will be able to see a lot of codes that were already prepared by my colleagues at IBM Research. And you can go through an example. For example, here we have a tutorial on credit scoring. And I'm not going to go through all of the codes here because that's not the purpose, but I just wanted to show the structure of a notebook. because all of them follow the same structure. So once you see it, then you kind of know the logic and you know what to look for. So first, we always start with some sort of import statements. And here we import the necessary libraries, machine learning libraries and packages. After that, we go on to loading the data set itself that we want to work on. And we can do whatever we like at this point. We normally do a train and test split in our data set. So we can do that here as well. And then after that, we will start measuring fairness on our original data set or on our original model. And then we have a look or if there is any existing bias in there. So if there is one, then we normally get on to the next step where we try some sort of bias mitigation techniques. And there are notebooks technically for every single algorithm that I showed you on the screen previously. So you can go and practice with that and have a look how they actually work and try to mitigate the bias in your particular example. And then once you mitigate it, then you can have a look again at how it worked out, whether you managed to eliminate bias in your case or not. So in this case, you can see that it worked very well. And yeah, so there was one more thing I wanted to show. And if I just go back quickly to the original page. If you are not really into coding, then you can do some demo here as well. And some of these actually are based on examples I mentioned in this presentation. So we uploaded the Compass ProPublica recidivism case. So let's say that in that case, we want to see how we can debias this machine learning algorithm we have here. So we load the data set, and then after that, we start training a classifier, and then we see what we have. So here, as we can see, the first attempt is quite biased, and we have 5 bias metrics here, and this algorithm is actually biased in 4 out of 5 metrics. Here we are looking at a protected attribute, which is sex, and we wanted to make sure that we don't discriminate against the female here. So this algorithm is actually discriminating. And in the next step, what we want to do is to debias this algorithm. And to do that, then we are going to go and we are going to choose a bias mitigation algorithm. Now, this can be familiar for you already because I showed you some of these previously. So let's see, we are deciding to use reweighing. The nice thing about this page is that it actually tells you what these bias mitigation techniques are for and how they actually work. And then with that, you can be a little more familiar with this particular topic as well. And now in this example, we are going to mitigate the bias with the reweighing algorithm, and we are going to have a look how it actually worked out. And I might need to stop my video for a moment just to make sure that my internet connection is actually allowing me to do that. Let me just stop my video first. All right, sorry. So we are training the classifier now with the reweighing algorithm applied. And as we can see, it is going to work us in this case very well because it debiased our algorithm across all of the metrics. And in that case, yeah, so none of them are actually biased anymore. If you want to learn more about the metrics that are used, this is again a handy tool here, and you can have a look and see what the ideal values are, and just to remind yourself. So I love to show this this little demo to my clients normally, and to anyone who is interested in this particular topic, because I think this really puts everything into context for you. And yeah, so definitely that was it. That was what I wanted to show you in this particular presentation. And I hope that I managed to achieve what I promised in the beginning, to speak a little bit about AI fairness concepts, definitions, and see how we as data scientists normally work, and what steps can be actually applied in order to debias our machine learning algorithm. We learned a little bit about open source toolkits and also about IBM proprietary tools. And yeah, so I will stop here for now and have a look if there were any questions at all. Okay. So there was a question about Arturo regarding AI fairness and the human context of it. And it was like this. The human mind is complex. Yeah, so technically he's saying that we need to teach the machine learning model about how complex our human mind is, and what we would like to see as fair. That is absolutely a good view on this, and that's exactly what I tried to explain in the beginning as well, that sometimes there are, of course, when it doesn't work out too well, in a way that there is some sort of misunderstanding between the machine output and what we actually wanted to achieve with our modeling, and what we see as biased or unbiased. So that is exactly why I'm seeing it as a very important methodologies to make sure that we are actually checking for bias all the way throughout our entire machine learning algorithm building process, or even if you already have some sort of models in prediction, then it's always good to actually check the metrics for them as well. And then Bob develops a supply chain network. Can we use these bias and fairness algorithms? Yes, absolutely. So if you have actually some sort of work in progress already, then don't hesitate to get onto, well, you can do two things. You can always get in touch with us. I will actually show one more time at the end what our contact details are, and you can always get in touch with us, and then we can help you and guide you through the process. But if you want to, then you can try it by yourself as well, and then you can have a look at all of those materials that we published on GitHub, for example. So as you can see, there are so many notebooks here which would give you like really good examples on how to start with this. And also, if you are stuck in some way, you are using these and you are not sure what's happening, then there is also a Slack group, and AI Fairness 360 Slack group, and you can join that as well and ask questions. And many of my colleagues from IBM Research are there as well, who were actually the ones who put together the AI Fairness 360 toolkit as well. So feel free to engage with the community, and also the data science elite community could be also helpful for you, because there are a lot of people, not only from my team, but also other data scientists worldwide. So there is always a helping hand if you want to know a little bit more, or you are stuck at some point. And I think I also promised that I would show you a little more about research and materials. So yes, so maybe it's a question to Fabiola. I'm not sure if we are actually sending out these materials to the audience. If yes, then I would recommend that you read through some of these research papers as well. They are absolutely fantastic, and they will give you some further information about all those concepts that I mentioned on today's call as well.
Yes, I think we can share them. If you can share it with me, of course,
Okay.
we can send them. And I actually can have a screen, a print screen, and I can share them via Facebook Live that we have this space. So if you want to have it there, we can have it. This talk will be, it's going to be recording and we were going to put it on the YouTube channel. So we have all the information you want online.
Okay, great. Absolutely fantastic. Let me just go back to the beginning then, just to show my full name and everything one more time. If you want to know a little bit more, you can always contact me directly, either by email or LinkedIn as well, or I can guide you through to the community pages I mentioned as well. Yeah, so more than happy to help.
Thank you, Ana Maria. Actually, it was a great talk. I think we have many more questions, but less time. So I don't know if you want to check. We have some other questions in the chat. They are asking if you know any resources for the data sets. Maybe also look at localized data sets in different languages, such as with which kind of language, and how do you handle all this kind of orthography, maybe something more complex as words written wrong. Like I believe this was like a mistake on the writing, but yeah.
Okay, oh, I'm sorry, but I'm not exactly sure about other language, whether it's actually in Spanish or not. That's a good question. I'm definitely in English, but yeah, so
yeah,
that I don't know, but we can have a look. And I'm not sure I
yeah,
understood the second part of the question, to be honest.
yeah, they put it here in the chat. But actually, answering that last question, we have a talk with Nextibia, and they show us how to do a transcript tool. It was really interesting. So I can share with you, Renee, this information with the video, so you can check. They say a little bit more about this kind of questions, so it can help you. And Lorenzo also asked something here. It was more based on the most important first process on AI fairness is to understand business, but also understand relevant data prior to modeling, evaluation, and deployment. In your experience, which one is the most critical or complex, and why?
Yeah, so yeah, absolutely spot on. So, but as for what is the most important, and that's a good question in a way. I normally say that if you go through the entire cycle of data understanding, data preparation, modeling, evaluation, then you should start bias mitigation as early as possible in the cycle. So if you can already adjust the data, then do that. So yeah, the sooner you do it, the better. But again, as I mentioned previously, unfortunately, sometimes you are just not allowed to, because you are not allowed to see, you are not allowed to access the data, or you're not allowed to massage it or make any changes to it. So in that case, you sort of have to get on to the next possible way of doing it by either the modeling part or just massaging the output of the machine learning model.
Great. So I think that's it. We have no other questions in the chat or in the Q&A. Well, last question. It says, how do you tackle AI fairness for the LGBTQ plus community? Are there any experience you could share?
So technically, you should be able to set your protected attributes or variables. So if you want to make sure that you don't discriminate against LGBTQI, then you can actually make sure that the machine learning model understands that there shouldn't be any discrimination based on that attributes. And this is something that you can change in the modeling phase as well, what you want to focus on. Yeah, so you just have to define it for yourself, what we want to look at or train your model for, but that's absolutely possible to include that as well.
Great. Thank you, Ana Maria. Well, I think that's all the questions we have, and it was a great talk, and we'll be happy to have you back in another time.
Thank you.
Thank you to all the team of IBM. It was a great talk, and hope we see you soon.
Thank you very much. Thanks, everyone, and have a nice evening. Bye-bye.
Yeah, thank you all to the attendees, and check our pages so you can check all the information and all the other talks that we have. And we see you later. Thank you.